And next, I'd like to introduce Paul Savage, the CEO from Nextek Power Systems of Detroit, to speak to DC Microgrids and Building Component and Systems. Paul, the podium's yours.
Thank you very much. Between the good meal and thinking so hard over the Z Factory presentation, I almost passed out. So it's good to stand up, see you all. It was a delight to drive here from Detroit and go through all those great wind installations and seas of solar panels. Makes me feel good. So DC Microgrids, the title I came up with the organizers, I think it's what we're doing in DC power systems and standards is really good for all weather, but it is nicely expressed in the idea of a net zero environment. So this is almost the entire presentation in a couple of sentences, so if I can share this with you, the rest should go easily. The big idea behind DC is that we live in a DC world. It's not quite obvious, but everything electronic consumes direct current. And we have these billions and billions, literally, of power conversions that go into those devices. If you believe Cisco, and they seem to be an authority in this area, over 100 devices a minute are joining the Internet of Things. And so you might ask yourself, do you want all those 100 devices a minute to have a switching mode power supply attached to them, like you have the wall warts at home or your laptop charger that turns the AC into DC and releases heat? Oh, no, is the answer. Sorry. So if we have a way of shrinking, I'm going to show you we do have a way. In fact, it's going like wildfire. I liked the earlier comment that we used to get together and talk about what could we do, and now we're all doing it. There is so much activity in this space. I would tell you with my Nextek hat on, we have quoted 3,000% more square feet this year to date than we did last year for the full year. And we were busy last year. So there's a whole lot going on, and I like being in the company of architects because I know architects have that professional fiduciary responsibility to their clients to do the right thing. And I hope I'm about to convince you that not only is it the right thing, but it's also the more cost effective. Not parity, it's actually cheaper now very often, and it deserves your attention. This is a little reminder to send you to the Lawrence Berkeley Labs website if you're interested in what I get done telling you, because they have quite a lot of information there that they've done to research DC power systems and DC loads around the world, although it will be immediately out of date, as it is every month, because of how quickly things are moving. So why? Well, I gave you a little hint there. We're in a room. I always count up how many AC to DC conversions there are in a room. Wife loves it. Here it's 250-ish, give or take, and then there's 300 to 400 personal devices on your bodies that are all DC power consumers. So we've got kind of 600-ish DC power devices in the room. Extend it to the whole building, and it gives you an idea of how many AC to DC conversions go on. You probably have more than one cell phone charger. You probably got 3 or 4. 1 billion power supplies wind up in landfills every year because of these portable devices and the changing interfaces for them. So that's one reason. I think I skipped to the end there about e-waste. If for no other reason, like the EU decided about, 8 years ago now, they required all the cell phone manufacturers to deliver a mini USB charging port because they were sick of having all those cell phone chargers be obsoleted every year. The EU thinks that single change for that single device has saved them 150 million power supplies from the landfill a year. So that's one reason. Compatibility with renewables and storage, both of which are completely denominated in direct current. So you can simplify our connections to these power sources and these elements of our power systems. And it fits the same trend that we've seen in technology for centuries, this oscillation between centralized and decentralized mainframes and laptops, virtual mainframes. like IT, and you'll see, I talk about that in a second, that there's a massive convergence going on between our information systems and our power systems, and hopefully when the power system becomes so much more like the internet, or as one of my friends likes to call it, the internet, it will not have to be rebooted as often as our computers have to. So you see a couple of pictures there in the upper left-hand corner is a little trailer that we developed with the IEEE. Everyone know who the IEEE is? Does that ring a bell for people? What a great organization. It's the Institute of Electrical and Electronics Engineers, which it's the 450,000 electrical engineer wingnuts around the planet. They all get together and talk about how to make technology serve mankind, and they have awesome events. If you look into it and it sounds interesting, I recommend it, because everybody wants to be at an IEEE event. There's no one that has to go. Everyone's just dying to get in there and tear it up, and you wind up with a lot of, but you also wind up with a whole lot of passion and commitment, and for the IEEE, they've been able to field volunteers in parts of the world that don't have energy access to help install these scalable DC microgrids that can provide more or less immediate access through the sun. The guy in the hat is Ray Larson. He's a researcher out at Stanford University who runs this IEEE Smart Village program, who's just an amazing person and has done so much good to bring not only these systems to Haiti and now across Africa, but to develop economic benefits around them that can help these areas which invariably need economic help as well. So they're kits or they're ready-made products. Both have come out of that. The state of Kerala, I'm going to mention the eMERGE Alliance. I'm the current chair of a standards organization called the eMERGE Alliance, which is promoting DC power standards as a way to grease the skids to get this stuff into the market. And we're excited to have welcomed a sovereign member of the eMERGE Alliance, the state of Kerala. The big picture down there, which is, I get choked up when I see it, that is NTT Facilities, Nippon Telephone and Telegraph. They had a DC microgrid in Sendai Prefecture near the epicenter of the Fukushima disaster, and it was the only source of electricity for 2 weeks. So this was the biggest ad you could ask for DC power systems. Our lighting systems are in that building, and it turned out to be a great advertisement for what DC can bring to cities or towns or really any building's plans to become more resilient. So I promise I'm gonna drive it down to particulars, but these are still some more general things which I think are interesting to note. One is LEDs. LEDs are here, except in this ballroom. They're everywhere, and there are no new buildings. You cannot, I would wager, you have not designed, if you're a designer, or specified, if you're a specifier, a building with fluorescent lights. You don't do it anymore. It's all LED. And that is an intrinsically DC device, so that's a great example, and for us it's been a great product to bring to market, or a load for us to add to our DC networks and buildings to really deliver value to the customer. As I might get to later, we can now put LED fixtures out in a building that don't have a driver in them, so there's nothing to break in them. It's just the LED light source and bent metal, or a little chandelier bulb, if you like. So that's complete and happening, and that's a great big part of the picture. The Internet of Things, touched on that. The confluence of power and data. So that Cat5 cable, you see the Category 5 cable there and the wires. Are you aware that there's now more and more power that's getting pumped through those cables? It used to be data only. And then about 8 or 9 years ago, they dedicated 2 of those wires to power. That's how you can power your smartphones on your desks at work. It takes a little bit of power that it needs for its display from the Category 5 cable. Well, now they're trying to dedicate another pair of cables, and maybe even another pair of cables inside of that bundle to get you more and more power at the end of the pipe, along with that information exchange. And they've probably already gone overboard. I'm part of the faction that thinks that you're not going to make progress going back into the National Electric Code and relitigating what gauge wire you should have for how much power. That sounds to me like a lifetime of complaint. But what's amazing is that there's a proper confluence between power and energy, such that there are power line carrier technologies now that will deliver full bandwidth Ethernet connections on just 2 wires. You can deliver through your power supply wires now a path for data without extra wires at all. So it's amazing if you think about it, because electricity comes in sort of natural packets. We turn them into binary packets when we want data to come along with them. But there's this realization that more and more of that is happening on a DC platform. Then, of course, the climate impact. It's amazing. I could have had 3 or 4 slides since I made the deck for all the disasters we've seen in climate, and I won't preach to the choir on that. So there's this mesh network. My company is involved in turning out DC power systems for buildings. The nonprofit I'm a part of is dedicated to establishing standards for systems like mine or near enough like mine. But we don't need to change the whole world, because the grid's doing it for us. This idea of a mesh grid, where we're having more and more peer-to-peer transactions of power, maybe sharing through the utility company for now, but as we've seen, I was just talking to someone about the city block, a company outfitted for sharing power in Brooklyn, New York. This is an inevitable turn of events to share power between customers without going through the utility, and maybe not even going through the meter. That's a little blockchain symbol up there. I certainly can't devote as much time to blockchain technology, but who's confused about what Bitcoin is or blockchain technology is? Only 3. No, I bet you're all confused, right? Does anyone here own a Bitcoin? Oh, there you go. That's amazing. 4 or 5. It's a fascinating thing, and if you haven't taken the time to understand it, I recommend it. And not just because it ultimately relies on low voltage DC power systems, but because it will give you an idea about how the internet has provided this foundation, not just for something having to do with transactions like Bitcoin, but also having to do with contracts of all sorts, and the relationships that we have, person to person, organization to organization, and government to government. It's fascinating. I took our company from New York City to Detroit in 2005 because I felt like there was a big convergence going on between stationary power systems like the ones you have in buildings and mobile power plants like we have in electric and hybrid electric vehicles. So at that time there was no intersection between stationary power systems like we have in this building and what goes on in a vehicle, whether it's an electric or a hybrid electric. And I thought at that time that the object in the upper right-hand corner, that's an IGBT 6-pack, isolated gate bi-directional transistor maybe, IGBT. They exist in every solar inverter, IGBTs, and they were coming up in these electric drivetrains for vehicles. But I was fooled. It was not the IGBT that broke the barrier between stationary and mobile electric power systems. It was Elon Musk, that sneak. He brought the battery, that Panasonic battery, which was part of portable devices. He brought that same battery into the car, and then he brought it back again to the power wall. And that's the first time that a key component has been used in stationary systems and mobile power systems. So it's interesting. It fits into my thesis. I didn't make me famous, but it's happening, and it's clearly happening, and it will happen more and more. So to get into some specifics, DC power systems are cropping up everywhere. Besides that eye-popping jump in quoted square feet I just mentioned, we're seeing real things go into real places. That upper left-hand corner is the American Geophysical Union. That's under construction now. They decided to go with a full DC infrastructure, ripped everything out, gut retrofitted the building. We're distributing 380 volts DC around the building, and we're adding solar to that bus without going through an inverter. And that bus is powering lots of loads in the building, not just lighting and control, which has been my bread and butter, but now also at the desktop. Every workstation at the American Geophysical Union headquarters on 2000 Florida Street in Washington, D.C., every workstation has DC only. So your laptop, I think you get an under cabinet light and you get a monitor, and you have a 100-watt limit, and they're talking about giving you a kilowatt hour limit for the week, which if you bump up against, they will scold you somehow. I don't know. I can't send you home, but they might. Then down at the bottom, that's a Whirlpool plant in Greenville, Ohio, a 200,000 square foot expansion of their manufacturing capability, all with a DC bus serving LED lights in the low voltage format. I was shocked on my drive up here yesterday to get a call from a provider of construction data who was trying to sell me his service to buy information about ongoing projects around the country, to tell me that we popped up on his sales lead list because of how many low voltage DC power systems were being specified. And I said, oh yeah, name me 3. And he did, and it was our product, and I had never heard of them. So this is you know, for a technology startup, which I guess we were 5 years ago, maybe we're not anymore. This is an amazing thing to find out. I did notice that we've gone from alternate in the bid for a building to the base bid, which I knew was exciting, because if you're the alternate, people in the construction industry know you have to fight your way in to get considered in a project. But if you're the base, then the alternates have to push you out. So this is an amazing change in the environment for these systems. And there's nothing to fear. If you're a designer or specifier in the building business, the way we get jobs done in a DC format looks exactly like the way you get jobs done in an AC format. And we've got architects at my firm that can speak architect with you and look at an alternate layout for a building, or you can browse our design resources guide on our website that will help demystify what's going on. We've also developed a AIA and GBCI accredited course if you need continuing ed credits, so you can learn about DC microgrids. We call it DC Microgrids 101. And get your continuing ed credit for your professional license. So another great thing for me, exciting development for us, has been new loads popping up and coming our way. A company in Chicago that makes those commercial shading systems had a new twist on the mechanical element of those shades, which is quite interesting. But he wanted to also innovate in the power and control. He came to us, and it turned out to be one of the easiest engineering projects ever to power and control his shades. A couple of weeks later, we're in one of the biggest buildings in the world getting the specification. And that's because someone with a low voltage DC device was trying to innovate how they got into a building, and they sought us out. So every time we add something to this low voltage platform, like the shades, or video cameras, or ceiling fans, we make a very efficient ceiling fan, pulls almost no current at all. It raises the value of the system. That's the workstations I mentioned. So that's a Samsung 27-inch monitor. It pulls 24 watts at 14 volts. That's a 7-watt desk lamp. That's a 60-watt max Apple MacBook Pro. And what's different, what you haven't seen, we're able to deliver these kinds of loads because they have external power supplies. We just don't plug them in. But what's missing from the equation and having it really take off and fly is the lack of standards. Right now your laptop is taking 19.5 or 20 or 16 3/4. There's no standard to build to, which is why we started this eMERGE Alliance effort. And as a bridging product, that little faceplate you see has got a programmable output, so you can put a barrel jack into your laptop and dial up the voltage that it needs to get to this incredibly low power consumption for the building. They're going to hit the 100 watts per person, and of course they're designing to less than a watt per square foot on the lighting, because the trend has been lower ambient, higher task, and we've got the task light right before them. So this building with not a lot of roof space is going to wring out of that solar array a net zero profile over the year. It's another fascinating area, the controls end of it. If I was giving this talk 2 years ago, I could have said, for rules of thumb, that to put wired controls in your building would start to run at about $1.50 a square foot. No one would have argued with me. Wireless control, I could have said it starts at $2 a square foot, $2.50. Again, I could have defended that mightily. Now we're putting in really sophisticated control systems in buildings for $1, 75 cents, 27 cents a square foot. So what you're trying to accomplish in terms of control inside of a building is getting a lot easier to do because of this promulgation of low voltage DC power supplies. If you think about it, every place you've got some point of control, a meter, a monitor, a sensor, all of those things are low voltage DC devices. And so they're going to favor installations where you've got low voltage DC power around to serve them. Displays in retail stores. If you get back to your browser and search for edgeshelf.com, you'll find out that Kroger is planning to put a 4-foot wide, 4-inch tall video screen on every single one of their shelves in the store, and not just for advertising. Although they plan to advertise, they will get rid of that paper shelf tag that provides pricing information to the customer and get rid of the requirement of looking after paper shelf tags, which if you've got 60,000 SKUs in a retail store, it takes 2 weeks to turn over the pricing. And now they'll be able to do that with a mouse click, as they like to say. So that's my flagship product. That's the only commercial plug I'm making with a picture. And I'm proud of our little box. It won top 10 at from Green Building Magazine this year. The big benefit over last year, our product of a year ago, is that we can now deliver the output modulated to the point where we can dim and turn off the light fixture at the end of the pipe. That's why we're able to get that driver out of the fixture. Again, a couple of years ago, if I was making that claim, I'd say we have a couple of dozen lighting fixtures we can offer with our system. Now that's thousands. So we have not discovered yet, even with big dog architects or owners, a lighting scheme that we can't handily replicate with DC versions of the fixture that you have in your mind. So it's a great big opportunity, and there's lots of companies interested beyond ourselves, not just power distribution in the building, not just power, low voltage power to displays of every sort, but also EV charging. That's a classic gonna happen, but will take so long it's hard to see situation, electric and hybrid electric vehicles. But that's another place where Fast charging is going to be either of interest or absolutely required in the form of the military's interest. But also batteries. Batteries come to the rescue with EV charging, because if you want to do a fast charge at your house, and so do your two neighbors, and you do it at the same time without coordination, you've brought down the block. But not if you have integrated storage. If you've got storage on your side of the meter, you can organize your system to give you a fast charge and not show that spike to the grid at all. And that is a whole lot cheaper to implement in a town, city, state, country, than bringing three-phase electrical service to every place you might want to do fast charging. So we're seeing more and more of these customer side of the meter strategies come to the rescue. And I think EV charging will surely be one of them. So we've gotten recognized. That's what I had to tell you. I did want to just mention that these ideas that we heard about earlier today about the specification and the standards that go along with specification, I know they've seemed like a pain in the neck in the past, standards, but I just want to say that the opportunity to create standards that promote the use of renewables and promote the integration of storage is more like standard in the old-fashioned sense, like a flag on the beach that you can rally behind. That's the good kind of standard. Okay, thank you.